The Merlin family of rocket engines is a series of Kerosene engines designed by SpaceX for their Falcon 1, Falcon 9, and Falcon Heavy rockets. One of the goals of SpaceX is to reduce the price of space travel, so the Merlins are designed to be relatively low cost compared to other rocket engines. SpaceX engineers also kept reusability in mind when designing them. The most recent engine in the family is the Merlin 1D. The engine produces 845 kilonewtons of thrust at sea level, with a specific impulse of 282 seconds. This is a lower efficiency than many other engines and is partly due to the fuel choice. The engine burns RP1 and liquid oxygen. Despite the moderate efficiency, this design choice does have other benefits. The engine has a very high thrust-to-weight ratio. Each engine weighs only 470 kilograms. This gives it a thrust-to-weight ratio of almost 200, one of the highest thrust-to-weight ratios of any rocket engine ever produced. The Merlin uses a gas generator cycle, where a small amount of fuel and oxidizer are mixed in a preburner. The hot gas created in this preburner is used to power the turbopumps before being dumped outside the engine. This engine cycle is less efficient than other engine cycles, but allows for very high thrust. On the Merlin engine used for the Falcon 1, the engine used the exhaust from the gas generator to control the roll of the rocket. On the Falcon 9, this feature was removed, as roll is able to be controlled when the rocket has more than one engine. One interesting feature of the engine is the ability to use fuel as hydraulic fluid. The turbopumps bring the kerosene to high pressure, where most of it is fed into the main combustion chamber. But some of the high pressure kerosene is used for engine gimbaling and for the grid fins on the Falcon 9 first stage. This means the rocket does not need its own hydraulic system, reducing overall weight. This is one of the advantages to using RP1 over more efficient fuels such as liquid hydrogen. The Merlin is able to throttle down to about 70% of full thrust. This throttle ability allows for greater control and accuracy when landing the first stage. The vacuum version of the engine produces 934 kilonewtons of thrust in space, with a specific impulse of 348 seconds. The vacuum version is also able to throttle much deeper, down to 39% of full thrust. This deeper throttling is probably used to more accurately place payloads into specific orbits. The engine has the ability to restart multiple times during flight. This gives the Falcon 9 the ability to boost back to the launch site, or to a drone ship where it can land and be reused.
LG-1, the Falcon is landed. Landing operators moving.